First of all, welcome to the course on analog and digital communication, ECT 305. Okay, so the first module we will be studying amplitude modulation. In the first session, we will be studying amplitude modulation, equation and spectrum for an amplitude modulated signal. In the next class, we will be studying what is DSP-SC and SSB systems. Amplitude modulation, an introduction to what is amplitude modulation. The definition for amplitude modulation is very simple. The amplitude of the carrier signal is made proportional to the instantaneous amplitude of the modulating voltage. This means that you have two signals here. One signal is called the carrier signal and the other signal is the message signal. Instantaneous amplitude of the modulating voltage. This means that you have two types of signals. One signal is the carrier signal, which is going to carry your message signal, and the other one is the message signal. So a message signal may be something random. You have a carrier signal with a particular particular amplitude and phase and frequency. So these are the three important parameters that is going to define a signal: amplitude, frequency, and phase. So naturally we have three types of modulation. The first type what we are going to study is amplitude modulation. The second type is very common. You might have heard of FM radio, frequency modulation. The third type is phase modulation or angle modulation. All these are dealing with analog communication because all the signals what we are going to study is analog. In the first module we will be studying only analog modulation. Second module and third module we will be studying random signals, and third module onwards we will be studying digital communication. Okay, so the first part, amplitude modulation, in which the amplitude of a carrier signal is made proportional to the instantaneous amplitude of the modulating voltage. I'll give you a very simple example and I'll try to explain to you what is amplitude modulation. Now when I am speaking to you, I'm generating an electronic signal proportional to my voice. It would be very random, it will be a zigzag signal or something. I want this signal to reach a far distance. I want this to be transmitted. That is all about communication. You have a receiver at one end and you have a transmitter. You have a receiver here, you call it as RX. You have a transmitter at the other end, TX. So from transmitter I am generating the signal and I am transmitting it to the receiver. Okay. So when I want the signal to reach a far distance, I have to modulate it because I have to give more energy to it, so that this signal reaches the other end. Okay, this process is called as modulation. Why we need modulation is a very important question that we'll see as we go on in detail. Okay, so that first you get an introduction to what modulation is, then we'll go in detail about why we need modulation. This is a very common question. This appears very commonly in your exams. Is that okay? So what we are doing is that we have two signals. One signal is going to carry the message signal to the other end. That signal is called as the carrier signal. This carrier signal will be varying in its amplitude according to the message signal, so that the message is embedded inside the carrier signal for transmission. Is that clear? So when the amplitude of the carrier signal changes with respect to the amplitude of the message signal, we call it as amplitude modulation. Are you all clear with what is amplitude modulation? Any doubts? So let us consider the carrier voltage or the carrier signal to be something like this. Vc is equal to Vc. Whenever I use a small letter, it means it is an instantaneous value. That means that it changes in accordance with time. Small vc means the signal changes in accordance with time. Modulating voltage or the message signal or Vm, it is also something that is changing with time. Let us denote Vm by Vm sine omega m t. Omega c and omega m are the respective angular frequencies. Okay. Omega c will be 2 pi into fc, where fc is the frequency of the carrier signal. Okay. Angular means we take it in a circular manner. Okay. The other one is the regular way of doing it. Okay. Understood? So this is an example. In amplitude modulation, you can see that you have a message signal and the carrier signal is getting changed. See, this is the message signal. This is the message signal and this is the carrier signal. A carrier signal is embedded inside the message signal and the output of this will be the amplitude modulated signal. This is the thing what we are going to transmit. Okay. In frequency modulation, it is shown in this particular slide. In frequency modulation, instead of the amplitude, the frequency gets changed according to the message signal. In frequency modulation, as we go on, we'll see in detail. Right now, you can understand what is amplitude modulation and how a message signal is amplitude modulated. Carrier signal is an ordinary signal that is being generated using any kind of oscillators. Is that okay? Frequency spectrum. What is meant by frequency spectrum of an AM wave? Frequency spectrum of an amplitude modulated wave. The frequency components present in the AM wave are the carrier wave and the first pair of sideband frequency, where a sideband frequency FSB is defined as FC plus or minus FM. You might have noticed that, listen here, you might have noticed that you have a signal like this, right? And you have another one like this, right? Another one like this. This is called as the, sorry, I'll just erase it. I'll use multiple colors for you to understand. This is the carrier signal and let this be the message. So you have, here you understand that you have two frequency components, right? One frequency due to the carrier signal, the other one frequency due to the message signal, right? This red represents carrier signal and this blue represents the message signal. So you have this two frequency components. We call this as sideband frequencies. One is FSB. So you have plus 1 and minus 1. So frequency for the upper sideband will be FC plus FM and frequency for the lower sideband will be FC minus FM. So you totally have three frequency components. One is the frequency of the carrier signal plus two sideband frequencies. Okay. So when you draw the frequency spectrum of an amplitude modulated wave, you have to draw all the three frequency bands. So this is an example of the frequency spectrum. You have the amplitude here, you have the carrier here, you have the lower sideband and the upper sideband here. Repeat, when I say Fc plus Fm, it comes to the upper sideband here, Fc minus Fm, lower sideband to the other end. Okay, next we are seeing a very important concept called as modulation index. While modulating a carrier signal, the amplitude of the carrier is varied by its instantaneous value. So modulation index is something that is going to define how far you have modulated a signal, or to what extent can you modulate a signal. In a modulating signal, while you are modulating, you are changing the amplitude of the carrier signal with respect to the instantaneous value of the message signal. Modulation index is going to determine to what extent have you changed, or to what extent has a message signal been changed, or to what level have you modulated the signal. So modulation index is defined as the ratio of the amplitude of the message signal to the amplitude of the carrier signal. M is equal to Vm by Vc. This is the carrier signal and this is the modulating voltage. You have seen that Vm will always be above this Vc, right? So modulation index M is defined as Vm by Vc for an amplitude modulation or an amplitude modulated signal. Modulation index is defined as the ratio of the amplitude of message signal to the amplitude of the carrier signal. Usually modulation index is a number that lies between 0 and 1. The maximum value is 1 and is often expressed as percentage and is called as percentage modulation. Let me make a point clear that every slide in my notes is a answer to a question. What is percentage modulation? What is modulation index? Define modulation index. Calculate the modulation index of a signal. They'll give you Vm and Vc and they'll ask you to calculate. Very simple answer. You can simply divide Vm by Vc and you will get the answer. Every slide, whatever I am teaching you is an answer to a question. So I am teaching you in a question answer model. That is why I say that everything you have to make notes very clearly. So when the modulation index is equal to 1, you will have a signal like this. So when I say modulation index is equal to 1, you can see that the carrier signal varies exactly with respect to the message signal or the modulating signal. You find this to be very perfect. So when the modulation signal is 0.5, you call it as under modulation. We have a simple example. This is an example where modulation index of the AM signal is 0.5. sorry 0.05, modulated to the least possible way. We call this as under modulation. That means message signal is transmitted as it is, or very, very slightly modulated. Modulation index of an signal when the modulation index increases, because the maximum value is usually between 0 and 1. But what happens when it increases? We call it as over modulation.